A teacher demonstrates convection in a liquid. She uses a glass tube as shown in figure 1.1. The tube is filled with water and left to stand for 10 minutes. A purple crystal is then placed in the mouth of the tube. This crystal dissolves and makes the water around it to turn purple. The tube is then gently heated as shown in figure 1.1. A. Suggest why the water is left to stand for 10 minutes before placing the crystal in the tube.
So what is the answer of it?
Sir, I wrote that so that the bubbles formed can escape, the shape of the tube is irregular. I wrote 2 points over here. I was unsure that which one should I write, so I wrote both of them.
Okay, so the question is asking you why the water is left to stand for 10 minutes before placing the crystal in the tube. So if you
Yes,
place
sir.
the crystal in the tube, what happens?
Diffusion happens.
Diffusion happens, and
Yes,
uh,
sir.
if uh, if you want to observe the diffusion properly, hmm, that means you you will see there is diffusion, and you will see there is convection current, right? Our experiment In our experiment, we are going to observe the um, convection process, right? Isn't it?
Yes, sir.
So, if we want to observe it properly, then we have to uh, keep our water settled first. Otherwise, convection current should go this way, right? From here,
Yes, sir.
yeah, the hot water will rise in this way, then it will go in this direction. But if our water is not settled, uh, we might see that some color will also come left side, some will go up, right? This way it will go, isn't it? Do you understand what I'm
Yes,
saying?
sir.
So what we have to do first, we have to wait for some time so that our water is remain settled, right? Calm water. Okay, so that we can observe the convection process without any error. Is it clear? So what you wrote again, say.
Sir, then my answer is wrong.
Yeah.
Uh,
So what should be your answer?
so that the water settles
Yeah,
in the tube.
so that we are allowing the water to be settled, right? Or to be still.
Yes, sir.
Okay. So write it, please, on your copy. Write it. Yeah. Hello,
Yes, sir.
Tamjid. Tamjid and Abir.
जी
Hello,
सर
Tamjid and Abir. What you wrote here in A, question 1A. Have you tried question 1 and 3? Hello.
Yes, sir. I wrote so that we are allowing the water to get settled.
Yeah, Tamjid, what you wrote?
স্যার এটা আমি লিখতে পারিনি এটা আমি
Okay, so you understand the discussion what we did with
হুম
yeah. So we want to observe here the convection process. So uh, if we are not allowing this water to settle, then there might be some shaking or the vibration of the water molecules, and movement is uh, the movement of water molecules will be left, upwards, in different directions, right? So that one will affect our convection process, isn't it? So that we can have the water particles movement only for convection, not for any vibration or shaking. Uh, that one we need. That's why we have to keep some time or wait some time for the water to be settled. Is it clear now, Tamjid?
Yes, sir.
Okay, write it. To allow the water to be settled. Okay, this answer.
Sir, আমার যদি so that the diffusion occurs only for the convection লিখলে হবে না কেন?
Yes, you can write that. You can write that as we are actually going direct answer. Huh? If you write that, that is also accepted. Yeah, we can accept that one. We can write directly about that one, so that water is settled. You write that one, also write this one beside. No problem. Okay.
Okay, sir.
Yeah. And then next part, when the water is heated, it is heated gently. Suggest why. Who got the answer? Yeah, raise your hand. Who got the answer? You have option to raise hand, right? Hello. Yeah, Abir raised hand. Yeah, what is the
Yes, sir.
answer, Abir?
Sir, so that the color would spread throughly or the heat will spread throughly.
So that,
The heat will spread throughly.
yeah, the color would again say, Abir,
The color would spread throughly.
slowly,
Truly.
truly.
Yes, sir.
Uh, and what about others, Ifaz and Tamjid?
Sir, I wrote so that the convection current can take place easily, uniformly.
Okay, so that the convection process can take place uniformly. Okay,
Yes, sir.
okay. Then Tamjid,
সেটা আমি লিখিনি।
okay, you did not write. So you understand why, now you can guess why we need to heat it gently. If you heat it gently, what Abis said, you said the movement of color thoroughly or slowly. What you say?
Thoroughly.
Thoroughly. Okay. Uh, what does it mean actually? Thoroughly, so that you can color can move thoroughly. What does it mean actually? Thoroughly. Hello. Can you explain little bit what you wanted to mean about this word?
The color spreads slowly or gently.
Gently.
Yes.
Okay, okay. That one.
So that
That
we can
is.
observe this.
Yeah, yeah, yeah. Then it is fine. And then if we heat it too much, or we are giving the heat, uh, you know, we are increasing the heat too fast, then the convection process will also be very fast, right? Then if it is so fast, then you will not get time to observe it. clearly that how the convection current is occurring here, right? Is it clear? Hello, is it clear to you, all of you? Hello.
Yes, sir.
Yes.
So
Yes, sir.
what you said, Ifaz, your one is correct, and what Abir said, your one is also correct. So the main thing is uh, to observe the convection process carefully. We need to heat it gently. Okay, then other related ideas also we can accept, like we can say like water uh, color would spread uh, throughout. If we give too much heat, then color would spread throughout too quickly. Then in other way around, we can say if we heat it gently, then it allows the color to move slowly. Okay, then if we give it gently, then we'll be able to see the convection current clearly. This way you can write anything. So write, please write, and tell me finally what you wrote. Yeah, Tamjid, what you wrote?
Yeah.
What you wrote?
To observe the convection process carefully.
Yeah, very good. Then Ifaz, what you wrote?
To observe the convection process clearly.
Clearly, very good. Then Abir, what you wrote?
So I wrote so that we can observe the convection process and the color spreading.
Okay, color spreading. Okay, excellent. So all are accepted. Then next, can you read Abir? This one, question C, part C.
On figure 1.1, draw an arrow to show the direction in which the purple color moves through the water.
Okay, so this one is easy, right? You just
Yes, sir. It will
will
be right
show
side.
the, yeah, you will show the arrow any way you can show, but it should be in correct direction, right? The direction should be correct. Like from here it goes up, right? The hot water rises up, right? Less denser molecules rises up, and a more denser molecule sinks down this way. So the convection current starts from here. Uh, you you can give arrow here like this. Hmm. Here or here you can give this place you can give, or anywhere here, right?
Sir, I give a arrow next to the crystal, right side.
Yeah, it's fine. It's fine. You are giving your right side. You can also give it here, right? Anywhere in the diagram, anywhere in the diagram you are showing, but the direction should be in correct. Uh, the arrow direction should be in correct order, right? Here also you can give. Huh? Is it clear? Hmm?
Yes, sir.
You can give here also. Huh? This way you can give. And if someone is giving like this, if you want to give the direction like this, you are drawing freehand. If you give this way circular, then that is also accepted, right? This way, if you show, like someone is showing this way, okay. If someone is showing this way, that is also accepted. Is it clear to you? Hello.
Yes, sir.
So anywhere you give arrow in the diagram, but it should be in correct order. Then you will get mark here. And then our last part, what is given in last part? Let's see. Yeah. State one safety precaution the teacher should take in this demonstration. So this one,
Gloves.
who can answer? Yeah,
Gloves.
gloves.
Gloves and safety goggles.
Yeah, gloves and safety goggles. Correct. Any more ideas?
So I wrote flammable things should be kept away from the Bunsen burner.
Yeah, flammable things should be kept away from the Bunsen burner. That is also accepted. Okay. So uh, in normally what happens? This is hot things, right? So to handle this type of hot things, we have to use the gloves, right? This is one point, and another thing is to protect our eyes from any kinds of heat or any because of too much heat there might be explosion in the tube, right? Isn't it? It might happen,
Yes, sir.
accident. So we should wear the even the hot water. It might come out and fall in your body or eyes. If it is on eyes, it is very much dangerous. So safety goggles we can use, and there is another option. Like while we are working, we can use a screen, right? That is third category precautions, but safety goggles, gloves, these are first category. And what you said, that one also we can accept, that removing flammable substance from the Bunsen burner, or removing it away from Bunsen burner, right? Is it? It's very easy, right? You understand it. So
Yes, sir.
we are done with question one now. And now we are going to question three. Let's go to question three. Question three is related to the very basic idea, right? Density. Determine the density of liquid. So Kamjit, read it. Read the question.
A student is given a quantity of liquid in a beaker and asked to determine the density of the liquid. Density is found using the equation density equals mass by volume. He pours the liquid into a measuring cylinder. Figure 3.1 shows the measuring cylinder after the liquid is added.
Yes,
On
then
figure
continue.
3.1, mark the position of the student's eye when he's reading the measuring cylinder.
So where should be the position of eye? You are using laptop, Kamjit?
Uh, yes, sir.
Yeah, so you can show where should be the position of eye.
Uh, Here, sir.
Sir, can I tell?
Yeah, yeah. You can tell. Just wait. See what he's doing, and then you can try it.
Here.
Yes, 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 yes. This is correct, right? Yeah,
Yes,
Abir,
sir.
Yes, sir.
Abir, is it correct?
Yes, sir.
Yeah. So you also wanted to say the same thing, right?
Yes, sir.
Yeah. Okay. So we are done with this, right? On figure 3.1, mark the position of the student's eye when he is reading the measuring cylinder. So you draw on your already you, if you have drawn, then fine. If you did not do it, now do it. Draw it on your worksheet also. Then A2. Explain why this position of the eye reduce error when taking the reading. So what can we write for this?
No parallax error.
No parallax error. Very good. Any idea from others? You have the same idea?
The
Hello?
yes, sir, no parallax here.
Yes, sir.
Okay. No parallax error. What is
To
parallax error?
avoid that.
Yeah, to avoid parallax error. Okay. Done. Good. Then the next one, 3, participate the volume of the liquid in the measuring cylinder. Yeah, Ifaz, what is the volume here?
78 centimeter cube.
Yeah, Tamjid, what you got?
78.
Yeah, Abir, you also got 78?
Yes, sir, 78 centimeter.
Okay, you all got correct one. 78. Then next, Abir, read it. Abir, B1.
State the name of another piece of apparatus the student needs in order to find the density of the liquid.
So what it
Balance.
needs?
He can use the balance scale.
Yeah, balance. Balance for measuring the mass, right?
Yes, sir.
So volume is already there. Now we need mass to get the density. So for getting mass, we need balance, right? So right here, balance or scale, whatever you like. Balance is mostly used. Then you read IFAS, this part, B2.
Explain how he uses this apparatus in this experiment.
Yeah. So they are asking about the balance, right? How the balance is used to get the mass.
Yes, sir.
So I will do it.
So first we will find the mass of the empty beaker, then the total mass, then we will minus them to get the liquid mass.
Okay. So any more idea? Tamjit, what do you think? Will you do the same way or in different way?
Uh, I think so. He's okay. He's fine.
Okay, it's okay. Then what about Abir?
Yes, sir, same way.
Actually, here we got already water here in the measuring cylinder, right? That is the point. Uh, Normally, we get the empty cylinder first, then we have water in other place, then we pour the water. That time we do the way you first told. But here in this context, already we have the water in the measuring cylinder. So first you measure the mass with water. Okay, is it clear?
Yes, sir.
So first you measure, just make it reverse. That's it. Okay, the one you said that one you make reverse, and there you mention here as already we have water. We should remove this water, right? To get the mass of only measuring cylinder. That one we can do by keeping this water in this beaker. The beaker is there, right? So what is the use of this beaker? To keep this water over there, right? Isn't it?
Yes, sir.
So first you take the mass of the measuring cylinder with water, that is M1. Then you keep the water or make the measuring cylinder empty. Okay, then you are having the only measuring cylinder without water. You get the mass M2. then subtract m1 minus m2 to get the water only, mass of water only, right? Is it clear?
Yes, sir.
Or if someone is saying in other way, like for the beaker one, they are using the beaker one, only taking the mass of beaker, then that is m1, then taking the water inside the beaker, again taking mass with the water and beaker, then m2 minus m1 is your mass of the water. This way someone can also tell. So whatever you like, you can write. That time the beaker should be empty, the first one. Uh, if you use the beaker, or if you want to use the measuring cylinder, that time the first step will be with water measuring cylinder. That mass you have to measure first. So write which one you like, that one you write. That's up to you. Have you written already, or you are writing now?
Sir, I have written.
Yeah, what you have written? Tell me.
Measure the mass of beaker with water M1. Take the mass of only beaker by keeping the water only cylinder by keeping the water in the beaker M2. Then find the difference M1 minus M2 to get the mass of water.
So what you said, the first step should be measure the mass of measuring cylinder with water, right?
Yes, sir.
You are taking the mass of measuring cylinder and water, right? So check it is written there or not. Is it written? That is M1, right?
Yes, sir.
Not the beaker. If you take first water, that should be measuring cylinder. Okay. Yeah.
Yes, sir.
Okay. So it's done, right? What about Tamjid and Amir? Have you written?
Yes, sir.
Yes, sir.
What you wrote, Tamjid?
Sir, I wrote simply first find the mass of the empty cylinder, measuring cylinder.
Yeah.
Second, find the mass of the beaker and the water together. Uh,
You
find the,
write then. You write that you are taking beaker's mass. Next one, water and beaker.
yes, second one is water and beaker.
Okay. Then first one, your one should be
Only
only
beaker.
only beaker, not measuring cylinder. Okay. That will
Okay.
be fine. Not measuring cylinder. Then you take the mass of beaker only, because you're now measuring the mass relating to beaker, right? Not the measuring cylinder. So
Okay.
you just take your beaker in both the steps, not measuring cylinder. You don't bring the measuring cylinder here. Only
Okay.
one thing you can bring, that you are taking the water from measuring cylinder to the beaker. Okay, for taking the second reading, isn't it? Isn't it? Hello,
Okay.
it's clear, right? Then, Abir, what you wrote?
Sir, I do take mass of measuring cylinder with water M1, then make the cylinder empty and take the measurement M2, then
Mm-hmm.
subtract M1 minus M2.
Very good, very good. Then we are done with B. We are doing now C. Okay, so Abir, you read it. C.
The student's eye is at the correct position when taking the reading. He calculates the density from his results. His teacher says that the value he obtains is different from the actual value. Suggest a reason for this.
Yeah, what could be possible reason? Any idea? Yeah. Any opinion, please?
Sir,
Hello.
I skipped this one.
Okay, you skip this one. You skip this one. What about Abir and Tamjid?
Yes, I did one.
Sir, I couldn't write this.
You did not write. No one wrote.
Yes, sir, I
No.
wrote.
Yeah, what you wrote?
Sir, I wrote there may be drops of liquid left.
Okay, okay. Drops of liquid. Yes, that one is the most important thing. Like uh, when like Ifa's one and Abir's one, if we are thinking that when you are making your measuring cylinder empty, that time still there might be some water left in the measuring cylinder, right? Isn't it?
Yes,
Hello.
sir.
So when you are taking it, that time you are getting, when you are taking this reading, that time the measuring cylinder's mass you are getting, that one is not only measuring cylinder mass, there is still some water, little bit water is there. That mass is also included, right? Isn't it?
Yes, sir.
So your experiment or your measurements will not be 100% accurate that time. Is it clear?
Yes,
The
sir.
same thing is happening for the way Tamjid wrote, like the beakers one. If we are transferring the water into the beaker, that time also we are having some water left in the measuring cylinder, isn't it? Hello. So we
Yes, sir.
measured the volume from their measuring cylinder. That was correct, but the mass, if we are leaving some water over there, so the part of mass we are missing here, because we measured that volume for that mass also, right? The one is still left in the measuring cylinder, so it is also coming inaccurate density. So you write it, huh? You write it. And there are some
Yes, sir.
more points are over there. I will give you the mark scheme. You check that time. Like there might be some when you are transferring the water, that might some water might fall, right? When you are transferring from measuring cylinder to beaker, isn't it? Yeah, one or two drops might fall down, right? That time we are getting the error. Or there are some more points. We will have them in our mark scheme. Okay. So is it clear?
Yes, sir.
Okay. So we are we done with this one? Yeah. Question 3 is also done. Question 1, 3, and 4 done. Now we have left question number 2, right? Hello. We have left this one, right?
Yes, sir.
Hello. So you join after after 5 minutes, okay? And then we will continue this part. Question number 2.